So we're going to talk about how water-based paints dry, more specifically acrylics, but most water-based paints will dry in the same way. So the fairly obvious thing, and what we've got here is a little diagram of the dark blue is water, the light blue in this case is the acrylic binder, and the little red dots are the pigment, obviously not to size. As you can imagine, if you've ever used especially acrylics, they form a skin on top. In other words, as the water evaporates off the top, the acrylic starts to join together and form a skin, but it's still wet underneath. If you've ever spilt a whole lot of paint and not noticed until it had been dry for some time, even days later, depending on how thick it is, it can be quite wet underneath, but really quite dry on the top. And that's exactly what we see here, which is the acrylic on a molecular level or microscopic level anyway, as we can see here, starting to push down and deform with the surface pressure of the air and capillary action dragging the water out between those little beads of acrylic. Now that will continue to happen, but of course it happens from the top. The water evaporates off the top more, and that's why we get the skin forming. Bit by bit, as these little beads are pushed together, as I say, through the surface pressure and capillary action, they will coalesce. Coalesce means cure or actually chemically bind together so that they're left, or you're left with, a strip of plastic, which is what acrylic is, impregnated with the pigment. Two things that they need to be able to cure dry. So not just the water evaporate out, that will tend to happen. If you put your paints in the refrigerator, that will keep the temperature down. Now, while the water will still evaporate out, they won't cure because they need to be above about 12 degrees Celsius. And they do need, as I say, the surface pressure. Now, that's really not a problem if you're painting on the Earth. If you're painting on the moon, that might be an issue. So surface pressure is not really a thing that we need to worry about. But temperature certainly is. You have to have above about 12 degrees Celsius and really below about 30 so the paints don't dry too quickly. If we just take a step back, here before all the coalescing has happened, our diagram kind of has all of the little beads, while they are being sort of squished and bent out of shape. The diagram would be more accurate if they were joined together a bit more across the top and less at the bottom. And this would then be more realistic in reflecting how the water finds it harder and harder to get out because it has less places to actually evaporate out. So the thicker a paint or a varnish is, the exponentially longer it takes to dry. So what I mean by that, if you put on a varnish or a paint this thick, whatever this thick is, and it takes an hour for all the water to get from the bottom to the top, then twice as thick won't take 2 hours, it might take 24 hours for the water to get from the bottom to the top. And that's because, as we said, the top is closing off that whole time and there's less and less places for the water to be able to get out. And we need the water out for these little guys to coalesce or cure. So once all the water has come out and our paint or varnish has completely cured or coalesced, that means that this coating will now be completely impervious to water or anything else for that matter. Still remains flexible, but you cannot reverse that chemical reaction. Therefore, the film will be flexible, but it will be as tough as it is going to be. And solvents, unless they are really nasty, wicked solvents, are really the only thing that's going to be able to attack that film coating. So, for instance, when we leave paint dry in our brushes and come back a week later and it's really gone hard, that's why very hard, near impossible, unless you use really good cleaners, like some of the Matisse cleaners, really hard to get that varnish or paint out of the brush. Quite often people ask about using a hairdryer to speed up the drying time. As we've just said, that the paint will take exponentially longer to dry the thicker it is, and that's because the top closes off more quickly relative to how thick it is. It's obviously more quickly the thicker it is just over time. If you hit it with a hairdryer, the surface, you will close it off much more quickly, which then doesn't allow the water out from underneath. So whilst the top might be touch dry more quickly, the underneath will take a lot longer to dry. Now, in some instances, this might not be a problem. Block printing, for instance, you put down very little ink, so that's actually not too much of a problem. But if you have taken paint that's 5 or 6 millimeters thick, hit it with a hairdryer, then put another coat of paint over the top and hit it with a hairdryer again, what you've got the chance of doing is having really quite dry layers on top of really quite wet layers, and as those wet layers do start to dry, they're going to contract at a different layer above it, might in fact be dry, and actually might start to form cracks. Acrylics are much more versatile than pretty well any other paint in that respect, but still you have to be a little bit careful to avoid cracks. So now you know everything to do with how paint dries. And it wasn't that boring, was it?